Today the topic is acceptance angle, acceptance cone and numerical aperture. Okay, so consider this is one of the cross-sectional view of an optical fiber. That means optical fiber mainly consists of the core and cladding. Here we observe that the total incident light ray and refracted light ray is presented only in the core, not in the cladding surface. Okay, this is one of the acceptance cone, and here the light ray is incidented, the light ray incidenting with the angle of incidence theta I, and the light ray is refracted and then it has an angle of theta r. Okay, and then it is reflected and again it is refracted and the process is going on. Okay, so here we are considering that here it is outward, so let us consider that it is in the air medium. So that air medium means it is having the refractive index of n0. The core is having the refractive index of n1, cladding is having the refractive index n2. Okay, so to find out the value, we have drawing the normal from B to C. Whatever the light ray that is incidented is refracted, it is having the angle theta r. From the refracted ray, here it is represented as B, and now here we are drawing the normal that is represented as BC. So it is angle of theta. Let us consider this is one of the right angle triangle. Okay, so next, here the light ray is incidenting at the point A. Let the light ray is incidenting at the point A with the angle of incidence theta I. Okay, so by using the Snell's law, sin I by sin r is equals to n1 by n0. Here you should remember that here we are not using any cladding, only the core and air medium, so that n1 and n0. So sin I by sin r is equals to n1 by n0. Okay, so I is represented as theta I, r is represented as theta r. So sin theta I by sin theta r is equals to n1 by n0. n0 sin theta I is equals to n1 sin theta r. Okay, now here we have drawn the normal, but we don't know the values of what is the actual value for theta I and theta r. But here we can represent the value of theta r. That means whenever we consider the triangle ABC, this is one of the right angle triangle. So theta r plus theta is equals to 90 degree. Theta r is equals to 90 minus theta. So substituting the value of theta r in the equation 1, we get n0 sin theta I is equals to n1 cos theta. That means, so after that n0 sin theta I is equals to n1 cos theta. Now here we have to find out the value of acceptance angle. Acceptance angle, it is a maximum angle of incidence, so it is represented by theta A. When it is represented as theta A, the theta value will become the critical angle. So n0 sin theta A is equals to n1 cos theta C. Sin theta A is equals to n1 by n0 cos theta C. But we are having the value only critical angle, that is sin theta C is equal to n2 by n1. So from that formula we are calculating the value of cos theta C. So here the cos theta C is represented as cos theta is equals to root of n1 square minus n2 square by n1. Now substituting this value in this equation, sin theta A is equal to n1 by n0 into root of n1 square minus n2 square by n1. So sin theta A is equals to root of n1 square minus n2 square by n0. Okay, so if we consider that the air in the n0 is the air medium, n0 is equals to 1, then sin theta A is equals to n1 square root of n1 square minus n2 square. So sin theta A, which is known as the maximum angle of incidence. So what is meant by the acceptance angle? It is defined as a maximum angle of incidence. All the process is done in the core, so it is defined as a maximum angle of incidence at the core of an optical fiber, so that the light can be propagated through the fiber. And what is meant by the acceptance cone? That is, we are to rotate the acceptance angle about the fiber axis, we get the incident cone with the semi-vertical angle as theta A, so that the light can be propagated through the fiber. And next is the numerical aperture. Numerical aperture means the numerical aperture is light gathering power of an optical fiber. That means it will gather the light will be totally gathered into the fiber. Okay, so the numerical aperture NA is directly proportional to theta A. NA is equal to sin theta A. That is, what is the value of sin theta A? NA is equals to root of n1 square minus n2 square. But according to the fractional index of the refractive indices, delta is equal to n1 minus n2 by n1. So n1 minus n2 is equal to delta n1. Now root of n1 square minus n2 square can be written as n1 plus n2 into n1 minus n2. And substituting the value of n1 minus n2 in this equation, root of n1 plus n2 into delta n1. Now I am considering that n2 is equals to n1. That means the total function is representing in terms of n1 because it is in the core. So n2 is equals to n1, root of n1 plus n1 into delta n1. The total NA is equals to n1 into root of 2 delta. Okay, so if the examiner ask the question right about the numerical aperture, we should not write the simple this topic. The total we have to write from the acceptance angle, acceptance cone. From this we have to represent. Okay.